In this video, I'm going to explain the source code of our blood pressure monitor project. This is the part of the series where I will explain the whole source code involved on the Arduino blood pressure monitor project. Let's start with line 1. On line 1, we have include wire.h. Wire.h is basically the I2C library for Arduino. So we need that because the EEPROM of the EEPROM of the blood pressure monitor is I2C interface. So you can check that on the previous video, the details on how it is connected to the blood pressure monitor. The next three lines will be what we call macro definitions. These are the GPIOs of the Raspberry Pi, or the digital pins that we use for the project. We will start with BP start pin. It is connected to pin 2. This is actually the start button of the blood pressure monitor machine or device. But this is already replaced by a transistor. So the transistor is the one that we control. So we can turn on, or we can say that we can command the blood pressure monitor to start. This is the button that starts the blood pressure device, the blood pressure monitoring device, and this is a transistor that we put in, and then this wire is the one that is connected to pin D2 of the Arduino board. Next is the valve pin, which is connected to D3 of our Arduino board. This valve pin checks if the measurement is done. So after we toggle this pin 2, we will now continuously monitor the pin 3 so that we will know if the device is already done and if it's time to get the measurement. This wire, this point here, is the pin that is connected to the valve. That is the one that we monitor via the pin D3 of the Arduino. Pin D4 will be used to indicate that the measurement should begin. This is not part of the blood pressure monitor device, unlike this pin 2 and pin 3, because this is dedicated pin of the Arduino board. This pin indicates that a measurement should start. This can be connected to a switch, push button switch, or another MCU or Raspberry Pi. The idea here is this Arduino will get the data from this blood pressure monitor device, and then this Arduino will transmit that data to a separate microcontroller. That's a separation of job. So this push button here is actually simulating that a different microcontroller that will get the data. So that microcontroller can be connected in this pin 4. This is the pin 4. And then it will send command on the Arduino that it should now start the machine, get the data, and then transfer it via UART. Of course, the Arduino is getting the data via I2C. Let's continue the discussion, and now we're here on the global variables. The global variables are all volatile because they are part of an interrupt service routine. So the byte I2 data Rx indicates that there are available data from the I2C bus. The count variable is a counter in which indicates the total number of data collected. So later on, I will discuss that further, but that's how we use that variable. And then these three variables are just the stores the measured values, measured values, which are the systolic, diastolic, and heart rate. Let's now proceed on the void setup. This should be straightforward, and you'll see this in a lot of Arduino projects. So we will send out the data via UART, and the baud rate is 115200. Then uh, these three initializations are for the GPIO pins. As what you've seen here above, we will have a macro definitions here so that we know the function of each pin. At the same time, if we want to change the pin location of this, let's say we want to move the start pin to pin 5, you could just change that to 5. So you can basically choose any pin you want, or if that's already occupied in your project, you can just change this number and the pin will be changed on whatever digital pin you want to connect these functionalities. So the BP start will be an output because this control the transistor, the transistor switch to start the blood pressure monitor device. This bulb pin should be an input because it monitors when the bulb is open or when the measurement is finished. The measurement begin will be an input because this is the one that is interfaced to a different microcontroller that is commanding our Arduino if it needs to start the measurement. So I put a pull up here because I'm doing it with the with the push button here, but if it's already connected to an external microcontroller, this should only be an input. Okay, let's now proceed on these two. Wire begin is the initialization of the I2C peripheral of the Arduino. You can look at this URL if you want to see the explanation here in Arduino website, but it's basically just an initialization. If you put an address there, it will be a slave, and if it doesn't have any address, it will act as master. And as you see on our previous video, our Arduino will act here as a slave. So we're basically using the address of the EEPROM is 0x50, hex 50. So that's the one we will replicate, or we will copy, so that whatever data is sending whenever the ASIC or the controller of the blood pressure monitor starts to send data to the EEPROM, the Arduino can listen to it, and then that's the time that we can sniff the data. So the Arduino should be the same. The Arduino should be the same. Now let's proceed on this one. So wire on receive is an interrupt based. This is it. This is the interrupt initialization. Initialization for the I2C data. So what will happen here is the moment that there's a data on the bus going to this address, our Arduino will listen to it continuously, and there will be an ISR or an interrupt service routine that will capture that data. So let's check this on the website of Arduino again. So this is the link where you can find the documentation. So basically, it's a function to be called when a slave device receives transmission from a master. What it means is that the slave device, which is the Arduino and the I2C EEPROM, will receive the data coming from the master. That is the data of the blood pressure measurement. So we need to create this function so that we will be able to get that information. So let's go back on our code and let's see how we implement that. So we will skip first the void loop, and then we proceed here first on the receive event. So this is the interrupt service routine that will get that data. So the iData will represent if there's a data going or coming. So if it's zero, nothing, there's nothing. So we don't need to execute here anything. But if it's greater than zero, meaning there's a data coming, we need to capture that data. So there's a while loop here, and then it will just continue to get that information. And based on my testing, I was able to capture that stream of data by using this print serial print, documented serial print command. Actually, this variable is already replaced. That variable should be that one, because this is now, because that's the old variable that I'm using, but just for a consistent documentation, and since it's updated, we have to update it as well. So during the time that I'm developing this, I always print all the data, but as you know, there are many data that we don't need, and you only need those three data. And since I already know where are the specific locations, I could just remove this. So the data are in this location, 28, 29, and 30. I will show an Excel sheet of the summary of data. So during my testing, these are the data that I was able to collect. So as you see here, there's the count from 1 to 30. During the transmission of data, I actually see many data here. But I know what are the actual systolic, diastolic, and heart rate measurement, which are located on this location on 28, 29, and 30. These are not exact address location, but these are the location or the index once the blood pressure monitor device start to send the data to the EEPROM. So this is repeatable based on my testing. So what we need to do is just listen and get the values on index 28, 29, and 30. And that's what we do in our code. That's what we did on our code. So if the count is, or the index is 28, that will be systolic. If the index will be 29, that will be diastolic. And then if it's 30, that will be the heart rate. So that's how we actually get the data and from the blood pressure monitor device. So this is independent on the void loop, so that will keep on running. And actually the data will only be present once we start the button. When once we start to give a command that the measurement should begin. So I think it's now time to proceed on the main loop function. So as you see here, after the initialization of the loop, there's only one big conditional statement here. So we are checking if the pin measure begin pin is actually 0. So since this is pull up, we're actually waiting for that button to be pressed. Just look at this video where I hit this button and then it starts measuring, because yeah, it pulls it to ground and then it will now start to measure. You will see start BP check and then BP ongoing, and then the pump will start its job to put air on the cuff. So let's go back to the code. So what happened here is when the switch that I put there, the push button, is pressed, the BP start pin will be toggled. It will be high, then low. That simulates let's put comment here. The Arduino is instructed to start getting data or start the measurement. Okay, and then this lines of code is actually toggling or simulating or emulating emulating a push on the button. As you see, we were able to start this without pressing this button. If you look at it starts automatically when I did press that button. When I press this, it starts on its own. But we don't push that. The Arduino pin here commands this transistor to to do that pushing mechanical push there on that button. So once that button is pushed, what will happen is we will delay for 2 seconds, and then we serial print start BP check as what you see on that video. Then we delay again for 202 seconds before we start checking the bulb pin. We need this delay to secure that the bulb is already closed, because if we check it when we check the bulb pin immediately, there's time in my testing that it's still not yet closed. So we have to check that. So we will continuously check it. So this will just print BP ongoing, BP ongoing, BP ongoing until it's done. So if you look at the video again, let's put it a little bit here. Yeah, it will just keep going, BP ongoing until such time that it stops. So let's, okay, 160, let's a bit more. Oops, 134, it's still beeping. Okay, there you go. So it's done getting the data, 148, 115. So when it's done, you will the bulb pin will actually become 1. So you will get out on that loop, and then you delay for 2 seconds, and then the Arduino will start to toggle the switch again. So it will simulate a push on that button. That push is needed because that's the time that the data will be transferred. So when the data is transferred, we delay 500 milliseconds again, and then we can now start to check the count. As you remember, when the data is transferred, the data will be automatically collected by this interrupt service routine. So the count will have a value, this sys will have a value, dia will have a value, heart rate will have a value. So ideally, this should have values. So this is our condition. If the count is 0, then there's no data, because the data here, because there was no count here, it never went into this loop. All right. So go back here. Where is that? Here. So if it counts as 0, no data. But if it's 35, just like what happened on our Excel sheet, it's 35. It means we have a good and smooth data. Then we can now print the blood pressure data. Else, it will be error. Because based on my testing, sometimes it goes beyond 35, because that will happen if there's an error on the machine itself. It will not give 35 values. So sometimes it's long. Like if you look at here, some data will reach a very long data, because that indicates some error. I'm not really sure. But if the data is correct, then it will just stay here on index 35. So, okay, so let's look at the video again. So it's done. So what will happen after 2 seconds here, the button will be pressed virtually because the Arduino is the one doing that. Then there will be a save indicator here. Let's see that. There you go. The indicator is not shown, but the data is now transferred, 148 over 115. I hope the explanation of the code is clear. It's a long video, long explanation, and lots of many complicated stuff, but I hope you can copy what I've done and use it on your projects. And by the way, as a last note, you can actually remove the BP ongoing and BP start check. You can comment this as well. And then when you transfer the data, you can remove this as well and just transfer the these two important data. So it's up to you how you handle that. But if you're successful in doing what I've done here, then you can actually edit this code and then interface this to ESP32 or to Arduino. Well, actually, I will do that again. I will do a video about that, sending this data to the internet. So it will be a separate video. I will link that down below. So, and it's an IoT blood pressure monitoring device. So I will do some modification here. So I will remove this unnecessary UART information because that's not needed. So probably will indicate just the exact values on the sys and diastolic. Just like here, I will just indicate these two. I will not indicate other unnecessary, yeah, other unnecessary prints like this one, BP ongoing, that's unnecessary, blood pressure, that's unnecessary. You just need to send 148 and 115. So yeah, if you find this video useful and informative, just please don't forget to like and subscribe on my channel. Thank you.